Alright, page 2. Alright, here's page 1. Page 2 on the Hospital a Day video. So doing some more, this is all heading for some other kind of subject, maybe unification, quantum, that kind of stuff, but getting to it from a different angle. So I'll go through some of the comments, the relevant ones anyway. Well, not that they're, the irrelevant ones are relevant only because you have to deal with these people. So anyway, this idiot, Space Child 59, who puts up nothing. Folk chemistry and physics. So right there is this it's folk physics, if anything else, shithead. But this whole, let's malign anybody who spends any of their time thinking about anything. If they don't go to college, they're automatically disqualified from the conversation. They're automatically ignorant. I mean, it's just such a sick, stupid, idiotic, useless thing to do on the internet. You're just such a useless sack of shit. Instead of tearing things down, why don't you show us? Why don't you build something, shithead? But no, you don't. You're just a sock account. I have no idea. Let's see. So he sees. You should put it at least in quotes too, if you're going to sit there and pretend to speak for somebody else. I have no idea about the latest scientific research of water molecule binding. Well, even if I did, how would that necessarily mean anything, right? There's about 4 million billion specialties in physics. You could know, there's way too much knowledge to have knowledge of everything. And if you're going to try to do any kind of unification thing or model thing, you really can't get lost in a bunch of obtuse and eccentric and nuanced specific findings, right? I don't need to know how water molecules are bound. I just need to know the principle, shithead. But I'll go ahead anyway and develop a model and argue it could be right. Yeah, but my model isn't really have anything to do with strictly molecules of water. It has to do with molecules of everything. That's right, shithead. I like it. So I guess it's a satirical little statement. But again, what value is this? Don't talk about physics on the internet. Oh my god, what a stupid motherfucking cunt thing to do. There's so many valuable. I could be talking about makeup. Or how to scrape your anal warts. Why am I wasting time having a conversation about physics on the internet? Oh, how obscene. God, you are just such a piece of useless shit. Space child. You're a fucking asswipe child. Fucking mother's a whore and your father's a retard. No doubt. You're the spawn of shit. No doubt about it. So fuck you. Anyway. Yes, alright, so right here, round 25, that's right, there is no model, that's right, and the model is sort of important in my opinion. That accuracy predicts natural phenomena, very unsatisfactory, but I'm sure the lack of a model is not through want of trying to find one. Yeah, well, I'm sort of not too sure of that. My take on the lecture was that Feynman was being totally upfront and honest about that. I don't think he was at all, so I don't know how you got that take. I don't know how you could take it any other way. He was basically closing the door to coming up with rational explanations for why things do things, and he says the math is the only thing that matters, and it just doesn't matter trying to understand the process. So I don't know how you get that interpretation. It's not his fault that nature doesn't always make it easy for us. Well, like I said, he doesn't say anything close to conceding that we just need to do some more work to find the right answer. He basically says there isn't an answer, okay, that the phenomenon is one built into some sort of nuance of math and not some sort of nuance of physics. I mean, that's almost what he's saying. So, I mean, I don't, like I said, I don't get where you get this crap from. He doesn't say anything ever about the fact that, no, we just got to make a better telescope, a better microscope. And then we'll see what the fuck's going on. We'll be able to deduce what's going on better. Because we'll just have to find some other way to observe a photon besides trying to throw photons at it. Obviously, you're not going to be able to see it that way. Anyway. Totally agree with your observation that physicists are dismissive toward the idea of there being a physical reason. I describe this as giving up. Yes, I totally intriguing thought to consider the workings of fiber optics, as in no energy cost for diverting the light. Okay, so that's all good. But as for your consideration to surface reasons for 4% reflection, Feynman discounted this by considering substance of layered different reflective indexes. Well, again, I don't think, there was problems with what Feynman was doing in his video. I mean, right from the beginning, like I said, 2%, then 4%. I mean, you got to say, what's that about? And then he did start talking about depth, and at different depths there's refraction or reflection, but that wouldn't figure, right? Because then you'd have an automatic amount of reflection per, inches of water, and that doesn't exist, so that's nonsense too. So I think it has to be a surface phenomenon. Because you can have very deep water that's very clear, and you can see a long way down if the water's pure enough. Anyway, let's see. Oh, here's got some new ones here. I describe this as giving up. He presumably describing the state of play. If you have a model, write it up and collect your Nobel Prize. Yeah, well, again, that's not the obligation, is it? I mean, we don't really have to provide the model to say it's worth pursuing a rational, logical model, and not be glued to some sort of dopey notions of wacky conduct at a distance or some other kind of bullshit. We can't explain it. They don't give Nobel Prizes for models of QM. Models of QM are called interpretations, and I think there are at least a dozen or so. You choose your fantasies. It is the nature of the beast, the nature of the type of theory QM is, that interpretations will be the best we can get with it, most particularly at the stage of history, since Planck scales are beyond us. Yeah, but they're not beyond us in theory, and that means that they're not beyond usefulness in terms of recognizing a model, recognizing a function. I mean, okay, I meant a non-probabilistic ping-pongy model that you, me, and for that matter Feynman would find satisfying. Well, of course it's probabilistic in the sense that it's going to still have the same functions built into it, okay? There's still going to be 90% of it's this form and 10% is this form, and so this 10% is going to always cause this 10% of a reaction. So if 10% of me was radioactive, the 10% that's radioactive would have an influence and a consequence. And so there's nothing about quantum mechanics that's wrong. It's just that it doesn't describe anything, okay? It doesn't describe function. It just doesn't describe the internal function. It just says what time it is. So it's like reading a clock. It tells you what the clock will say, but it doesn't tell you how the clock says it. Yeah, that's what I want to say. All right. It seems to me the only hope for such a model will come from, that is to be provoked from, gaining far better abilities in the realm of the small. QM is just too accurate, effective on all known scales, since the hypothesis of those uncomfortable with it mostly suggested is the realm of the Planck scale, where it will break down. This has always been the way new measurements, observations, and new phenomena prompts inquiry and hypothesis. So actually, well, whatever. I don't think it's all this damn. Yeah, I don't think it's gonna. I think it's gonna hinge on somebody figuring out something simple. Recognizing that it's going to be an Einstein moment here, right? And that's what's going to come. There's going to be somebody who's going to have an Einstein moment, and it's just going to make the whole thing make a hell of a lot of sense. You should watch the rest of the lectures. He shows how the amplitude formalism accounts for essentially all optical phenomenon. This is this stupid Roberto II guy who's a real QM whore. Why light travels in straight lines through empty space, why the angle, well, I mean, that seems obvious. Why the angle of incidence equals the angle of reflection, how diffraction, well, I did watch some more of his stuff, and it doesn't say all that stuff, and it doesn't provide explanations for any of that stuff, so that's just bullshit. Alright, so look, fundamentally, so there was two notes I added to the video. that I think are important. And so we'll deal with those first. So matter is vibrating, so that's a key element of this whole reflection thing. So the point is when light's coming down and it's going to hit a surface of some kind, the surface is vibrating, so it's moving a lot from the atomic scale. At the atomic scale, it's moving a lot. The atoms are jiggling a lot. So if there was a phenomenon where a certain arrangement of the atoms, where the photon would first encounter a hydrogen atom versus an oxygen atom, the vibration means that even if it was a stream of photons, a constant stream, the vibration would mean that this arrangement is constantly changing. So it would never be hitting the same circumstance. Even though it's hitting the same place on the matter, it wouldn't be hitting the same atoms on the matter, because the atoms are moving constantly. And you see some of these effects in, when they make certain compounds ultra cold, they gain ultra conductivity, and they can even, gravitationally, magnetically. There's lots of weird effects you can get, where they're, where you can actually have things hover magnetically, which is sort of an interesting phenomenon, right? And the explanation is in the fact that the matter is no longer moving, and that probably has something to do, or it's moving a lot less, and that has something to do likely with that effect. So I think there is a lot of effects that are tied to this movement. Now, Hothloday did leave a link to one of his other videos where he had a Susskind clip, where the Susskind guy basically says, okay, there could be a rational reason for this whole quantum mechanics phenomenon, but it's going to require faster than speed of light communication between particles. And I'm going to argue, no, I don't think that's what's required at all, if you recognize the fact that much of the frequency or vibration of matter is synchronicitous. Okay, so there would be a synchronicity built into the structure of each atom, especially in the moment of its creation. And that synchronicity is sort of what Feynman was talking about in terms of this circular kind of thing, this idea the clock keeps spinning. So when he's doing these angles of incidence, he talks as if it's a clock, and he has it going backwards, but that just might be a video effect. But anyway, and that what you're really doing is measuring time. Okay, he's big on this time versus space thing. So it's, and space is really just distance. And, figuring out events, as they happen, their duration and their incidence. The time is the scale versus the distance they travel. And this is metaphored in quantum mechanics by creating these vectors that are created based on this rotation. So they rotate through time in this direction, and the aggressiveness of the distance would be a function of the arrow. So that's this just re-represented in this form. And then when you do this vector addition, what you ultimately get will be some kind of angle between two events, and so that would be like the two slit experiment, or the two layers of material experiment, where the phenomenon seems to have a connection between what's happening in one layer seems to be affecting what's happening in another layer. And the argument is as this goes through time, the two things come down at the same rate, and one travels more distance, so it goes through more time, and so its arrow ends up in a different location. And then you take this arrow, place it at this arrow, and you create your triangle, and then you do your area, and you take your triangle out of your area, and that's your probability of the both events. Or anyway, that's the math is being done through this rotation of time. And so I would argue that that is in the essence of this phenomenon, is a recognition that the entire universe, could be on the Planck constant would be a constant of distance and time. So the idea would be that a quanta moves from point A to point B in it's a specific amount of distance, but it's also creating a specific amount of time. And that if the vibrations of all these things are connected to that clock speed, that, yeah, there would obviously be, so if you had two things happening separate from each other, but they had an initial same incidence point. So you have two things separated by distance, but they had the same initial point, and then they had a different clock position, let's say, at initiation, where one was at 2 o'clock and one was at 7 o'clock. They would rotate through their times independently of each other, and there would be a continuity, though. If they went the same amount of distance, they would be in the same positions relative to each other. They would have moved the same speed from their initial point. And so it would appear that there was a connection between the two, and that they still maintain some sort of symmetry or connection to each other, but the communication was merely because they had the same birth point. If you get my drift. They're carrying the echo of the same vibration. And so the echo of that vibration exists in both of them, but it existed in both of them before they even started. So I mean, it's not like it's not a true communication. The communication is merely a function of them both being related to some same point of origin, or same echo is the only word I can come up with. Let's say if I could shout into the universe and I could create vibration in everything in the universe, that vibration would be frictionless, and so it would stay in everything. Everything would retain that vibration forever. So everything would be vibrating at a vibration that's similar, and so it's going to go through its lifespan with that pattern still being retained inside of it. Whatever the pattern of that vibration is, that pattern will be retained. And so even though these things are separated, they both have a pattern built into them that is the same, because they had some interaction with each other in some previous point that made those that forced that pattern to become similar. Okay, that synchronized their pattern. So that synchronicity is built into the two particles before they're separated, and you can't extract that, because it's just a function of what it's doing. So let's say an electron gun is producing electrons. It might be producing electrons that have exactly the same pattern in terms of an echo inside of them, in terms of a loop or a behavior or some sort of fingerprint it leaves on them that ties them together in terms of what they're doing, like some sort of vibration they carry. And so there'll be effects of that sameness in the same moments in time, and there'll be a difference automatically in different moments in time. So if one hits the surface at a certain time, it will be vibrating, let's say, soft, and one hits, because it goes to another layer, its vibration will be hard. And it's only because this one is later in the pattern of the vibration. Yeah, well, this is really getting obscure. But I'm just saying this would account for what appears to be communication at a distance, because the communication is very crude. There's nothing hard about the communication, except that we know that this one's on at this plane, and we know this one's off at this plane, and it's always that way. This one's always on, and this one's always off. And why is that? Well, that's why, because they share this built-in pattern that is time dependent. So it's like this, at this point their clocks were synchronized, and now if they do travel different distances, they're automatically going to be on a different rotation of their clock. So one is automatically, if it goes more distance, it's automatically going to have a different vector because it traveled a different distance than, say, the other one that only traveled a short distance. And so they're automatically related to each other because they were related at some previous point and had their clocks synchronized. Okay, that's a good way to put it. So interaction creates vibration synchronicity. And once you synchronize their vibrations, you will automatically create these patterns of on, off, on, off. In terms of, let's say the off, it happens because the vector is like this, and the on, off is the opposite direction, or whatever the thing would be. But I mean, it has to do with, you could say that it has to do with their magneticness, or their spin, or something else. So you could just say this one is a plus, and this one is now in a minus state. So you could say that the thing was changing from its polarity would switch every 15 Planck constants, or whatever the amount of time is, because of the way it's vibrating or the way it's spinning. And that spin is dictating through time whether it's going to be on or off, or on or off, or on or off. So whether its polarity is plus minus or minus plus will be dictated based on how far in time it goes. And that's why there's this automatic reaction. If this one's on, this one will be off, and if this one's off, this one's going to be on, because they're both on the same clock. And that same clock is always created by them having some association, some connection previous to the incident. So all they have to do is have some previous, they could have a previous origin. I mean, obviously origin would make two things the same. Okay, they came from the same origin, same creation moment. Or some contact later where two things come in contact with each other and then they are synchronized. Yeah, okay. So what else did I want to get to? So I think it's just important to recognize that, okay, all contacts between particles and matter, or energy and energy even, all these contacts happen in an atmosphere where there is a lot of movement, vibration. So let's understand that one too, that it's not necessarily the movement of the atoms themselves. The atoms' nucleuses might be relatively stationary, but everything about them is vibrating. Okay, there's a hell of a lot of noise in what's happening. And that noise, that shudder, is constant and can have multiple frequencies built into it. So it could be carrying, it could be vibrating both very fast and very slow and all kinds of harmonics. So like in music, it could have a whole lot of tones built into the single wave of vibration. It can have many different degrees of detail. So, I could go dum, and that sound could be hard lines like this, but inside of that could be little tiny lines of frequency. So the frequency at which this is vibrating can be, looked at as this, but inside of all of that could be this, and even inside of that, there are even more sub-frequencies. So you can have a ton of frequency inside of that frequency. Frequency gets a little complicated, but you go with amplitude modulation, which is up and down, and frequency modulation, which is going sideways. But anyway, I'm just saying that you could have carrier frequencies, and then inside those carrier frequencies you could have lots more information in terms of patterns that are built into the structure of these particles when they interact with each other. And so particles that are similarly frequencied would interact differently than particles that have an inconsistent frequency. So obviously particles that are on this nice wave sign like this, and one shows up and his wave sign is exactly the opposite, obviously there's going to be a different reaction. The interaction between those particles is going to be different if their phase shift is different. And So I think that's the critical difference, and that's where all the probability comes in, is what's the average incidence of contact has to be within this range of time, and in that range of time there can be all kinds of degrees of phase, and the more in phase there'll be a certain event, and a less phase there'll be a certain event, and it could be again converted into a digital response in the sense that any phase shifts that are halfway off go automatically to a high, and any phases that are halfway low go automatically to a low. And so the new wave is created out of the two waves, and they're not blended. So they're it's all or nothing. So it's essentially a digital signal that's created out of an analog mixture, is another way of looking at it. It's all or nothing in terms of how the end product of the interaction would be. And the end product could be the release of a photon, or the end product can be some other phenomenon related to how matter interacts with each other. What else did I want to get to? Alright, the vibration thing I think is really important. This vibration thing is going to turn out to be really important. And what else is important? The Planck constant, the idea of even the creation of a clock speed, I think is another piece of this. It's not. It doesn't even have to be an actual clock speed. It's just the incidental, consequential clock speed. So again, I'm going to argue that the basic function is crude. Three-dimensional checkerboard. You have a Planck constant, which is a quanta. The quanta moves one Planck constant in time like a domino. It just flips. It flips in a direction. I would argue that things like electrons might just be quanta in a pattern where they are head to tail. And the trick would be in moving them would be that in all movement of, say, an orbital, you can end up doing this lots of different ways. I tend to think that the orbitals around atoms are actually, this is my perception of what might be going on, is that they are actually these rings that are intertwined. So that's why you have to break the ring, which is the strong nuclear force, to degrade the atom. And I haven't come up with a good explanation for the weak orbital, like how it might be connected, or might be an incompleted circle, and how that would even function, because there would be nothing to retain its circularity. Because let's just say this is positive and negative, positive, negative, that's keeping quanta connected to each other, that they do have a polarity built into them, and that's what forces them to connect. So this whole thing is built out of that connection. And if you want to move this atom, part of the trick would be is that it might have to go one more quanta in this direction, one more checkerboard square in a direction than what it would have done if it stayed where it was. And to go forward, it has to go one more, which means it has to go one less at the other end. So in a sense, it has to break one notch and then do the same thing. So that would be the limitation on its speed. So this ball would start to roll in this direction, right? Like if we just went one quanta forward each time. But the amount of time it would take would be divided by the entire number of Planck constants in the circle. So the size of the circle will contain so many Plancks. The Plancks are a Planck constant of time, and so that would dictate how fast this arrangement of quanta could move in any direction. Would be dictated by the fact that it can only move one Planck constant per 1 billion Planck constants of time. So it could only go 1 billionth, let's say, of the speed of light before some other degrade would have to happen to this structure for any part of it to move in this direction any faster, because it's already moving at the speed of light in this circular motion. Yeah. That's part of it. Something like that anyway. So this is what I mean by there's a model, there's a physical structure to this stuff that causes the phenomenon. And what we're seeing in the phenomenon is merely that there is relationship between what one thing does and what another thing does. So there's a relationship between photon A and photon B, okay, that exists. And what I would argue, and that even quantum mechanics is basically saying the relationship is strictly related to time, and where what state the matter will be in at a specific amount of time, because the rotation is now different with all time. So even though the photons might have been related at some previous time, been synchronized, and that's what we're seeing. It's just the product of that synchronicity. Yeah, I'll have to work on that one some more. But I think that explains the probabilistic nature and the fact that there does appear to be some connection between what one thing does and what the next thing does. Yeah, that the state is changed. But state changes can be created by there's a lot of reasons how state changes could take place. So you could almost argue that also when say photons are meeting matter, it certainly could be that the first photon that hits creates a vibration within the immediate area of where it hits, and that vibration changes the state and now forces the second photon to have a different reaction, because now the state has been changed by the interaction of the first photon. So these are other things that have to, and this would be totally dependent on frequency so whatever light frequency you had would certainly change whether you could go through a substance or not go through a substance. So yeah, light goes through, like infrared light will go through this window quite easily. Certainly visible light goes right through it, but ultraviolet light, this window is opaque. There's very little. You couldn't see the image in the ultraviolet spectrum through a window. You'd have to have something like crystal glass or something to be able to see through the window. And so obviously it becomes frequency dependent, and much of that dependency might just be that this phenomenon is dependent on what is created in terms of a vibration by the contact of this surface with photons at all. Yeah. Alright, well that's enough for now. So yeah, it's an even messier page too, but we'll see what the comments bring, see if I come up with any other notes to add. And maybe I'll make a list of the key points. So temperature, I think, is a key point, and the fact that temperature is just a reflection of vibration, and that everything in the world we have contact with, the normal world, is vibrating with temperature. And that's a key to understanding why there's a difference in reaction. You could even argue the two-slit experiment, when they do it, it's vibrating, and that vibration might be also part of the reason why there is the result that is achieved. But anyway, I'll get to that eventually. So enough for now. Till next time, and such. Video response is welcome, but yeah, fuck you, space child asshole. You got nothing to say, right? You got no contribution to make. Don't even have a relevant criticism, just an irrelevant criticism. Don't talk physics. You don't have a right to. Yeah, fuck you.